In this video 2-1 we will be looking at factors. By the end of the video and work time in class you should be able to say, I can identify prime and composite numbers and I can find the GCF of two or more numbers. We'll start with some vocabulary. Divisible is when you divide and get a remainder of 0. A number is divisible by 2 when, and here's the test, when it ends with 0, 2, 4, 6, or 8. So in other words, if you have an even number, it's divisible by 2. A number is divisible by 3 if the sum of its digits is 3, 6, or 9. A number is divisible by 4 if the last two digits are divisible by 4. So look at the last two digits. Okay. 5, it's divisible by 5 if it ends with a 0 or a 5. A number is divisible by 6 if it's already divisible by 2 and 3. It has to be divisible by both 2 and 3 in order to be divisible by 6, so that means it's an even number and then the digits have to add up to 3, 6, or 9. The rule for 9 is very similar to 3. A number is divisible by 9 if the sum of its digits is 9. And you keep adding the digits until there's one digit. If it's 9, it's divisible by 9. And a number is divisible by 10 if it ends with a 0. So those are the rules we'll follow when we're working with rational numbers, and specifically in this chapter, and specifically today when we're working with prime factorization and GCF, which is greatest common factor. A factor is an integer that divides another integer with a remainder of 0. A prime number is exactly two factors, has exactly two factors, one in itself, where a composite number has more than two factors. So some examples, let's say 57. 57 would be a composite number. And if you look at it, 57, a lot of people think maybe it's prime, but if you take the digits 5 plus 7, you get 12, and you keep adding those 1 plus 2, keep adding the digit until you have one digit and you get 3. If the sum of the digits is 3, 6, or 9, it's divisible by 3. So 57 is composite because not only is it divisible by 1 in itself, it's also divisible by 3, looking at that rule. Let's see, how about 43? 43 is prime. It is only divisible by 1 and itself. 1,354, that would be composite. It ends with a 4, which makes it even, so it's divisible by 2. 975 would be composite. It ends with a 5, so it's divisible by 5. Prime factorization is when you have a composite number written as a product of prime numbers. So a couple examples here. If you had 54, which is a composite number, and we're going to branch off. 54, we could do 2 times 27 is one way we could start this. The only thing we can't do is put a 1 in the tree, so I couldn't branch off 1 times 54. We could do 9 times 6, that would work as well. You just can't put a 1 in these prime factor trees. Once you get to a prime factor, circle it. You're not going to branch off of that anymore. 2 is prime. For 27, I'm going to branch here. 2 factors of 27 would be 3 and 9. And my smartboard is acting a little weird here in the middle. So we have 3, which is prime, and 9 is composite 3 times 3, and those are prime. So the prime factorization of 54 would be 2 times 3 times 3 times 3, which would be 2 times 3 to the third power, because 3 times 3 times 3 is to the third power. Let's do another one over here on the right side of the screen. 588 is a composite number. I know it's divisible by 2 because it ends with an 8. So if I divide by 2, which is prime, so I'm going to circle it, I then have 294, which is still even. So I'm going to divide by 2 again, which is prime, and that is a 2. 2 times 147. 147, if I look at the digits 1 plus 4 plus 7, I get 12, and 1 plus 2 is 3, so I know that 147 is divisible by 3, and it would be 147 divided by 3 is 49. 3 is prime. 49 would be 7 and 7, 7 times 7, and those are prime. So if we go back here, we have a 2, another 2, even though it doesn't look like it, 3, 7, and 7. And so when we would write this, we write them in order from least to greatest, but we raise to powers if we have more than one factor. That's the same. So 2 squared times 3 times 7 squared would be the prime factorization for 588. You can check your work by multiplying, doing that, finding the product, and making sure you're getting what's at the top of your factor tree. GCF is the greatest common factor. One way to find the greatest common factor, I'm going to show you 2 examples here. If I have the number 55 and the number 231, and let's say we want to know what do they have in common, what factor specifically do they have in common, so what can we divide them both by? Well, we can build our factor tree for both, so 5 times 11. The prime factors of 55 are 5 and 11, so 5 times 11 is the prime factorization for 55. For 231, we have, it's divisible by 3 because the sum of the digits is 6. And if I divide by 3, which is prime, I get 77, which is 7 times 11, and that's prime, and that's prime. So my prime factorization for 231 is 3 times 7 times 11. So I have my prime factorization for both. When you write the prime factorization when you're finding GCF, don't use exponents so you can see specifically what they have in common. In this case, we didn't need exponents anyways. So we look at both of our prime factorizations and we look at what they both have. Well, they both have an 11. I can pick off an 11 from both trees. That is the only digit I see that they have in common, or number they have in common, specifically the only factor they have in common. So that means the GCF is 11. You can divide both 55 and 231 by 11. Not only can you divide them by 1, that would always be a common factor, but the greatest common factor is 11. Let's do another one. We've got, let's say 54, which I need to get this smartboard fixed, it looks like, and 63. So for 54, 6 times 9 is 54, 2 times 3 is 6, those are prime, and 3 times 3 is 9. So my prime factorization for 54 would be 2 times 3 times 3 times 3. I'm not going to use exponents when I'm using prime factorization to find a GCF. For 63 it would be 7 times 9, 7's prime, 3 and 3. So we have 3 times 3 times 7. So we have the prime factorization. If you have more than two numbers, same thing, you find the prime factorization of all the numbers you're dealing with. Then you see what do they have in common. What do all of them have in common? In this case, what do 54 and 63 have in common? I just picked off a 3 from both trees, another 3 from both trees, and then they don't have anything else in common. So what I do is I multiply those two factors they have in common. 3 times 3 is 9, so the GCF is 9. Can you say I can identify prime and composite numbers and I can find the GCF of two or more numbers? In the output, I want you to find the greatest common factor of 120, 150, and 180. I want you to use 4 different colors when showing your work. So one color to write the problem out. Just the problem that's on the screen, write that problem out in one color. In another color, I want you to show all of your work. In a third color, I want you to write your answer and circle it. And then for the fourth color, I want you to check it. So you're showing in your check work that all 3 of those numbers are divisible by that GCF, which is your answer. Be prepared with questions for in class.